So now with that background under our belt, let's turn our attention to thinking about native human inference strategies. Let's start by just looking at some general kinds of inferences that human beings make. So we'll talk about general heuristics, context-dependent heuristics, and learned conscious methods. Then we'll talk about how psychologists categorize these into two general groupings, System 1 and System 2. We'll go on then to talk about the properties of System 1 and System 2 and how they potentially interact with each other in problem solving in the real world. So one thing we might want to ask ourselves is how good are human beings at making inferences natively? To answer that, we'll start off just by looking at sort of general inference strategies that human beings do employ. Now, the first tier of those strategies, the first group of those strategies are general heuristics. General heuristics are processes, tendencies of thought that get used by people across all sorts of different contexts. They are imperfect in that sometimes the assumptions upon which they're based are violated, so they don't always give us a correct answer, but they tend to be pretty reliable under the circumstances in which they evolved. The next tier that we might look at are context-dependent inference strategies. These are strategies that human beings seem to employ in specific contexts, but not generally. Now, psychologists group these two different inference strategies together into a single category that's named with the poor name, System 1. It's not really a system, though many of these inference strategies share the same sorts of neural resources. The idea here is that they represent a particular strategy or way of solving problems, and so we'll talk about that strategy in just a minute. Now we can contrast that with learned rules or conscious inferences. Psychologists group those kinds of problem-solving processes into what they call System 2. Now that we've got that categorization put together, let's think about the relationship between them. Well, reliability tends to go in this direction. System 2 inference strategies tend to be much more highly decontextualized. They take the underlying structure of problems more into account than System 1 strategies do, which tend to be very highly contextualized. And so they're less reliable. System 1 strategies are less reliable than System 2. Unfortunately, you have a much greater likelihood of using a System 1 strategy for solving your problem than a System 2 strategy, in part because System 2 strategies draw heavily on working memory, and in part because we evolved to solve a bunch of problems using System 1 inference rules. So what do System 1 inference processes exhibit? What sorts of properties have led psychologists to group them together? I'll give some major ones and then talk about things that are associated with those. So the first one is automaticity. System 1 inference processes kick in automatically. Whenever you confront a problem, your brain is automatically trying to apply one of the various System 1 strategies to solve that problem. Oftentimes, these strategies are innate. That is, we don't have to learn them. And in fact, oftentimes we're not very good at refining them as a result of experience. We do sometimes get learned procedures becoming routinized enough, that is, rehearsed enough that they become automatic as well. They're autonomous. That is, they don't draw heavily on working memory, if they draw on working memory at all. And for this reason, these System 1 properties tend to have little, if any, conscious awareness. So we're oftentimes not aware that we're making the inference that we're making. They have little conscious oversight. We're not consciously deciding whether or not that inference strategy is applicable or being executed well. And usually we have little, if any, conscious insight also. So we don't really know how it is we solve the problem exactly. Next, these systems are highly contextualized. That is, the information that is most often used is information about content, the specific features of the problem, the actual things you're trying to solve the problem about, and context, the way in which the situation presents those features to you. They operate associatively and in parallel. So they tend to be associative processes as opposed to serial and logical processes. And they tend to be pretty fast. They also tend to process larger and more complex amounts of information. So we consider, for instance, visual processing to be akin to System 1 inferences because they're done relatively autonomously, automatically. For instance, color perception is highly contextualized. Vision operates in a massively parallel fashion, and it's very fast. What about the other system, System 2? Well, System 2 is difficult to engage unless contextually cued. So we're always working with our working memory, but identifying problems and then using System 2 strategies to solve them is oftentimes very difficult for us to do, particularly if the situation doesn't suggest to us that we need to. Some psychologists say that this is because it requires cognitive decoupling. So we don't just have to view the environment that we're in. We have to now devote part of our working memory to representing and solving that problem. And that's very difficult for human beings to do because our working memory is so small. These processes are non-autonomous. That is, they draw heavily on working memory, and so the ability to do them varies between individuals significantly. There's a limited capacity for the amount of information that we can utilize and the complexity of information that we can utilize in solving these problems, unless, of course, we externalize that with writing the problem down. They tend to operate serially. We do one step, then another step, then another step. And they require conscious awareness, conscious oversight, and as a result, we have some conscious insight into how we solve these problems. Finally, they're highly decontextualized. That is, System 2 inference strategies tend to look at underlying structural properties more than they tend to look at the superficial content or context in which the property is presented. And they're often learned. They're part of a cultural heritage that we get through education and through training. Now, if we ask how it is that these two systems work, how it is that we solve problems in real life, we can think of a timeline for the moment we confront a problem and the moment we see a problem, the moment a problem is presented to us. Our System 1 inference strategies are already kicking in. They're automatic, they're autonomous, they're associative, they're highly contextual, they're trying to find a solution. Now, slower, and sometimes, in fact, often, not at all, System 2 might kick in. Again, it's difficult to engage unless we're cued to think that this is a statistics problem, for example. We're not likely to use statistics when we're estimating how likely it is that we should take this turnoff to avoid a traffic jam. Right? They're non-autonomous, so they require significant amounts of working memory. And of course, our working memory is largely consumed just by the information that's being poured in through our senses. They operate in serial, so they take more time. And they tend to be highly decontextualized. That is, they look at those underlying structural elements. If both of these systems tries to solve this problem, then there'll be some conflict mediation and resolution. For System 2 to give you the solution as opposed to that System 1 process, System 2 actually has to inhibit the System 1 process and provide that answer for you.